In this video, we'll draw the Lewis structure for IBr2 plus. This is the iodine dibromide cation. So let's count the valence electrons up first and then draw the Lewis structure. Iodine is in group 17, sometimes called 7A. It has 7, and then bromine in the same group, and we have 2 bromines. We'll multiply that by 2. The positive, that means we lost a negative charge. We lost an electron, so we'll subtract 1. That gives us a total of 20 valence electrons for the IBr2 plus Lewis structure. Since iodine is the least electronegative element, we're going to put the iodine at the center, and then we'll put the bromine atom on either side. We'll put a pair of electrons between atoms. That's going to form the chemical bond. Then we'll go around and complete the octets on each bromine. At this point, we've used 16 valence electrons. Each bromine has an octet, but the iodine doesn't. So we're going to put the remaining 2 electrons here on the central iodine atom. We've used all 20, and everything has an octet. This is a good Lewis structure. If we check the formal charges, we'll find out that each bromine has a formal charge of 0, and that central iodine atom has a formal charge of 1 plus, which makes sense. It's less electronegative, so it should have that positive formal charge. And the formal charge, that matches the charge on the ion. So this is a good Lewis structure. Since we do have an ion, let's put brackets around this. And then we'll put a positive sign out here. So this is our Lewis structure for IBr2 plus. Let's take a look at the molecular geometry. We have 2 atoms attached and 2 lone pairs. So the purple, that's the central iodine. We'll add 1 bromine, we add the other. They push away to be as far away as they can. Then we add the lone pairs. There's 1, pushes those bromine atoms down, and 2. So this is the molecular geometry. And this is considered to be a bent molecular geometry. If we hide the lone pairs, you'll see the molecular geometry, the molecules, they're arranged in a bent formation here. The bond angle should be about 109.5. That won't be exact. If we look at the electron geometry, so add back the electrons, we end up with what's called a tetrahedral electron geometry. Let's go back to our Lewis structures. If you use the AXE notation to figure out the molecular geometry, A would be the central atom, the iodine, X, number of atoms bonded, the 2 bromines, E, number of lone pairs. We have those 2 lone pairs. So you'd end up with this AX2E2, which if you looked up, that would be a bent molecular geometry. This is Dr. B with the Lewis structure, molecular geometry, and bond angles for IBr2 plus. Thanks for watching.